Customers are important to a business. I know, wild concept that. Let's look at some customer KPIs today. Welcome to this video on analyzing business data with T-SQL. My name is Kevin Fiesel, and I'm the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In the prior video, we took a look at financial key performance indicators, covering revenue, cost, and profit. In today's video, we are going to focus on some customer KPIs, along with a bonus. Because we have a lot to do, let's jump straight into the demo and talk about customer KPIs. Here we are in Azure Data Studio. I have several scripts open as we are going to spend a lot of time talking about customers and also introducing some nice functionality in SQL Server along the way. First up, a quick bit of functionality that SQL Server 2022 has to make life easier. Let's say that it is July 16th, 2015. The reason we're going to say this is that the core wide world importers data ends somewhere in this time frame, so this is about as far as we can go unless we add more data in. I have actually added some more data in, but if you simply download wide world importers and try these queries, this is right around where the data stops. Anyhow, one thing that we commonly hear from the business side is to collect data at a monthly level for analysis. If it's July 16th, how do we get the start of the month? Well, in pre-2022 T-SQL, we could use the DATEDIF function to calculate how many months there have been since the beginning of time until July of 2015. That answer is 1386. In case you're wondering which date marks the beginning of time, we can use the dateAdd function and add 0 months to the 0th month in history, conclusively proving that the beginning of time was January 1st of 1900. But just knowing the number 1386 isn't going to help here. No. We need to convert this into a date. So we'll use the dateAdd function to add our DATEDIF result to the beginning of time. When I run this, we get back July 1st of 2015, which is what we want. As of SQL Server 2022, there is a better way to do this, the DATETRUNC function. I can simply call DATETRUNC and say that I want the month, and it will helpfully give me July 1st of 2015. This function will help us out with our next KPI, where we deal with customer breakdowns. In the retail world, we typically fit customers into certain buckets based on their behavior. Exactly how we define these buckets typically depends on whether we're dealing with a subscription model, frequent shoppers, or occasional shoppers. For the sake of simplicity, I am going to define 5 categories as I lay out in a comment here. First, we have new customers. These are people whose first order was in a given month. This means a customer whose first order was July 13th of 2015 would be a new customer in July of 2015. Next, we have retained customers. These are people who ordered this month, and they also ordered in the prior month. A customer with an order in July of 2015 and an order in June of 2015 will be a retained customer according to this definition. Naturally, the next category to discuss is inactive customers. These are customers who ordered in the prior month, but not in the current month. If the customer had an order in June of 2015, but nothing in July, this is an inactive customer. The flip side to this is a resurrected customer. This is a customer who did not order in the prior month, but did order in this month. If our customer had no orders in June of 2015, but came back in July of 2015, that's a resurrected customer. Finally, a churned customer is one who did not order in either the prior month or the current month. Now, these definitions can make sense in a scenario like wide world importers, where the customers are retail stores and are making regular purchases from our import-export organization. If you were looking at people buying automobiles at a car dealership or subscribers to a web-based service, the definitions would need to be radically different. But given our definitions, I am going to show you how we can build our calculations of how many customers fit into each of the 5 buckets I've defined going into July of 2015. Because the month is not over yet, our analysis will look at May and June of 2015 to define those customer categories. I am going to build this query up in parts to make the explanation easier. First, we truncate the date to the month's start, July 1st of 2015. Then I need to get orders in the prior month. To do that, I'll get each customer ID and the count of orders from the orders table for this customer, where the order date is during the month prior to our month of interest. In this example, that's going to return any orders in June of 2015 on a per customer basis. I'll get back one row per customer. Importantly, because I'm using a left outer join, I will get one row back even if there are no orders for the customer. And because I am referencing a column in the orders table, if there are no matching order records, the number of orders I get back will be 0 instead of null, which means I don't need to wrap this in an is null or otherwise think about what happens if there are not any orders. We also need to go back to the month before, that is May of 2015. The calculation is very similar here, except that my date add function goes 2 months back. The final query in this bunch is to determine a first month that a customer placed an order. Notice that we can use DATETRUNC on column names as well, not just literals. Now that I've shown you 3 queries, let's run all of these together. This will give me back 3 result sets, with the first result set showing number of orders in June of 2015 by customer, the second showing me number of orders in May of 2015 by customer, and the third one being the first order month for each customer. With these 3 queries in hand, I can solve the problem. I'll put my first customer order query in a common table expression that I'm calling first customer order. Then I'll put together orders for June of 2015 and May of 2015 in one common table expression, using union all to combine the results. For the June 2015 results, I'll set the months ago flag to 1, and for May of 2015, I'll set it to 2. Notice that I also have a case expression, returning 1 if the count of orders is greater than 0. For our purposes, it does not matter if a customer has 1 order in the month or 100. They count the same either way. After this, we'll create a third common table expression called order details. For each customer, I'm going to capture the customer ID, whether the customer had an order last month, that is in June of 2015, whether the customer had an order in the prior month, May of 2015, and when the customer's first order was. I need to wrap the months ago case expressions in a max function because there will be 2 rows for each customer, and I want to get the correct row, meaning for last month order, I want to get the row associated with 1 month ago, and for prior month order, the row associated with 2 months ago. Once I do that, I can summarize the order details common table expression. The total number of customers is a simple count of records in order details, as we've grouped by customer ID, and each customer can have only 1 first order month, so that won't change the effective grain of this common table expression. Then I put together my simple logic. If our first order month is this month, then we have a new customer. Otherwise, we check their orders from last month and the prior month, defining whether we've retained the customer, if that customer is inactive, if we've resurrected the customer, or even if the customer has churned. If I run this query, we can see the results. We had 735 total customers in the system, none of which were new as of July of 2015. We retained 561 customers. 42 customers had orders in May, but not in June. 43 customers had orders in June after having none in May. And that leaves 89 customers who did not have orders in either May or June. This single row of results gives us a lot of useful information about the current health of the company. For wide world importers, they are not bringing in any new customers, and based solely on this one view of the data, there's some ebb and flow, with about 8% of current customers skipping a month of orders. We don't know exactly when the 89 churned customers left us, but they're gone. At least until they make another purchase in the future. Earlier, I mentioned how these measures could be different based on whether we are using a shopper model or a subscription model, so let me talk about that briefly here. Wide World Importers has a shopper model. People buy from the company whenever they feel like it. We know that our customer base is retail chains and online stores, so they're typically going to make fairly regular purchases, which is why we can think about activity and churn over a month-by-month basis. This would be similar for, say, grocery stores, but the formula would be very different for something like a retail toy store. In that case, You wouldn't expect a customer to come in every month and buy something new. Instead, you might expect a few purchases a year for things like children's birthdays or big gift-giving holidays such as Flag Day. Meanwhile, for subscriptions, our churn model is a lot easier to understand because we can look at active subscriptions. How many people are paying us month over month? In the subscription scenario, we don't need to infer sales activity based on month over month or period over period purchase behavior because we have a direct measure for sales activity. The ultimate formulas will be quite similar, though you may not need quite as many common table expressions or subqueries or complex bits of logic to get there. And now, it's time for an interlude. If you're a data warehousing professional, you are likely quite familiar with the notion of a date dimension. A date dimension is a simple way of gathering information about a given date without needing to perform any sorts of calculations or formulas. Instead, we do all of the calculating one time up front and pass the savings on to users. Here I have an example of a date dimension, or a calendar table. Calendar tables aren't nearly as common in transactional systems, but I do what I can to change that because of how useful this kind of table is. On this calendar table, you can see that I have dozens of attributes covering details like day of the week, whether this is a weekend, week of the month, month name, quarter name, calendar year, and holiday name. In addition, we have calendar dates and fiscal year dates. Many companies have fiscal years that begin on a different day of the year than January 1st. For example, when I worked as a state government employee, our fiscal year started July 1st. In addition, the US federal government's fiscal year begins on October 1st, so we needed to keep track of calendar quarter, state fiscal quarter, and federal fiscal quarter in a variety of systems. You could have developers calculate this out every time, but that's a waste and can lead to incorrect formulas. Instead, it's easy to note that December 30th of 2024 is in calendar quarter 4 of calendar year 2024, state fiscal quarter 2 of state fiscal year 2025, and federal fiscal quarter 1 of federal fiscal year 2025. What follows is a script that I've pieced together over time. It works for US English dates, as I'm making certain settings explicit on lines 59 through 61. Change those and you can use a different calendar format. Now, there are no promises that this script will work with other countries or with lunar calendars, as honestly I haven't tested those. I won't get into the nitty-gritty of this script as it is pretty complex. Instead, I will mention here that you can get a copy of the script, as well as all of the other scripts that I'm showing, in the GitHub repo associated with this talk. The link is in the description below. As I scroll through, we can see that there is an initial insertion of most of the date columns, and we can make use of a variety of techniques, including window functions, case expressions, the cross-apply operator, and even tally tables. But when it comes to holidays, we need to pull out even more stops. Daniel Hootmacher put together a blog post more than a decade ago showing how to calculate Easter for a given year. And Carl Schmidt has a great blog post covering a variety of other holidays, including lunar calendar holidays like Pesach and Hanukkah. Date math is quite complicated, so I am absolutely in favor of doing it once and making sure you get it right, rather than trying to copy this into various parts of your code base. I already have the calendar table, but I will note that a calendar table spanning from 1900 through 2050 took me about 18 seconds to create on this machine. It may take a little bit longer on your box, depending on how powerful it is, but the nice part is you don't ever need to do these calculations again. Instead, you simply join to the calendar table on date or date key and get your details. Looking at the top 100 rows in this table, we can see each of the columns that I've brought in. And one nice thing about a calendar table is you can customize it. If there's some special date logic you need to incorporate, you can do it here. I mentioned state and federal fiscal years, and there's nothing stopping you from adding your own custom holidays or swapping out some of these attributes for others that are more relevant to you. And if I go all the way to the right, we can see the holiday names at the end. Granted, this particular method of defining a single holiday for a date can cause problems. For example, 2024 is the first time since 1910 that the first night of Hanukkah happened on the same day as Christmas. If I query the calendar table, I can see one entry for December 25th of 2024, and its holiday name is Hanukkah. At this point, if you need to know about individual holidays, you might need a crosswalk table that combines date and holiday. Then it could also make sense to include an indicator flag for is holiday on the calendar table itself, so that developers can use the flag when the specific holiday doesn't really matter that much. Now let's get back to more of the same. We have a calendar table in place, and it's time to talk about another way that we commonly slice customer data: by geography. Wide World Importers breaks up states in the US into sales territories. There are 9 sales territories in total, and the external sales territory includes the Virgin Islands and Puerto Rico. Our query to get customers by sales territory is similar enough to prior queries that I won't spend any time focusing on it. Instead, let's put on our business user thinking caps and start asking some questions of the data. Let's look at the first order date for each customer and also include that customer's state code and sales territory. This query takes advantage of some constructs that we used in the prior video, a common table expression and the DATETRUNC function. But we can build up from this query and start asking questions like, how many customers do we get per region per month? Starting with the same common table expression, we can change the base query to include sales territory and calendar month, providing us the count of customers. Because count is an aggregate function and we have 2 non-aggregated columns, we need a group by clause with those non-aggregated columns. We'll also sort by sales territory name and first order month for ease of analysis. If I run this query, I can see 3 records for the external sales territory, 2 in the year 2015 and 1 in 2013. In the far west, we have a similar story with new customers springing up in various months, all the way up to 2020. One common request from the business side is, how does this period compare to neighboring periods? For example, if we have 1 new customer in August of 2019 for Far West, how does it compare to September or July of 2019? Granted, you could look at these results and get the information for the one sales territory, but if you'd like to do this across multiple regions, it can get harder, especially if your visualization tool does not have an easy pivoting functionality, or if your business user doesn't exactly know how to generate a pivot table. Instead, let's use a pair of window functions to solve this problem: lag and lead. Lag looks at the prior record within the context of a window, and lead looks at the next record. In the prior video, I touched upon window functions and mentioned that a window function is a function with an over clause. We used an empty over clause on a sum or count function to get totals. With lag and lead, we are going to dig into the over function just a little bit more. First, we have a common table expression to calculate customers' first order, just as before. Then we have our new customers by sales territory result set, which is the same as what we just saw. But now we have a new base query. In this base query, I am looking at the sales territory and calendar month, and then I want to display 5 numbers: the current month's new customers, the prior month's new customers, the number of new customers 2 months ago, the next month's new customers, and new customers 2 months from now. Lag and lead allow me to do this. If I include only the parameter new customers, we'll get the value of new customers for the prior row with lag or the next row with lead. But if I include a secondary numeric parameter, I can specify how many records to skip. So 2 here means we skip the first and show the second. Then in the over clause, we define our window. Each window has a partition by clause, and that acts as our window's filter. We partition by sales territory, meaning that if I'm looking at the external sales territory, I only want rows associated with that territory, not far west or anything else. Then I can sort the window using the internal order by clause. We'll sort by calendar month so that I can get dates in ascending order. Running this query, I can see the sales territory, calendar month, and some results. If there are no records within the window that match our lead or lag criteria, we will get back null. That's why the first row for external has null for prior month and 2 months ago new customers. We don't have any new customers for external prior to January of 2013, but we did pick up 8 new customers that month, and then we have the records for the next month and 2 months in the future. Except the eagle-eyed among you will have spotted a major problem. September of 2015 is not 1 month ahead of January of 2013. What lag and lead are doing is not figuring out the date context and checking how many records fit in the next calendar month. Instead, they're fetching the next record, and if there are any gaps in our data due to having no customers in that month, Well, we end up returning incorrect results. How do we fix this? It's time to bring in our friend, the calendar table, as well as a data warehousing technique that rarely gets play in well-designed transactional systems, the Cartesian product. We are, in effect, building a matrix in data visualization terms. That is, a complete set of rows and columns, with each row representing a value from one input, each column representing a value from another input, and each cell representing the intersection of these two inputs. In our case, think of sales territories as the rows, calendar months as the columns, and number of new customers for a given sales territory in a given month as the intersection of the two. This query starts out the same as before. We have our first order per customer, followed by the number of new customers per sales territory and calendar month. But now I'm bringing in two more common table expressions. The first one retrieves the set of months in my calendar table, starting from the first customer order and ending with the last customer order. That gives us our columns data. Then we get the distinct set of sales territories, giving us our rows data. Now, I've talked about this matrix and visualization terms so far with rows and columns, but I'm not actually going to deal with the data quite that way because that's really hard to query in T-SQL. Instead, we'll shape this as a tall table with attributes showing the sales territory, calendar month, and number of new customers. The way I can do this is with a Cartesian product or a cross-join. Cross-joins are kind of sketchy for online transactional processing systems, but it's exactly what we need here. Then we'll left outer join the new customers by sales territory virtual table, as the entire point here is to include a row regardless of whether we had any new customers for that sales territory and month. At this point, I am guaranteed to have all sales territories and all months, so lead and lag will work the way I expect them to. One row within the window of a sales territory represents 1 month. And if I run the query, this will take a moment and will return 855 rows. For many of these rows, we will see a series of zeros showing us that we are including those gap months. We can see 8 new customers for external in January of 2013. Then over the next 2 months, we see those 8 customers slide off. Scrolling down to 2015, we can see a pair of ones flowing through exactly how we'd want them to. And that's customers by geography. Now let's talk about one last measure today, customer retention rate. I have a comment here with a quick reminder as to our 5 categories of customer: new, retained, inactive, resurrected, and churned customers. In the first KPI we looked at, we reviewed one single month of data. Now let's take it to a month-over-month analysis based on what we've learned about window functions, calendar tables, and Cartesian products. We start off the same way as in the prior KPI, getting the first order for each customer. Then we have a second common table expression that includes every month in our span of orders. I do want to point out that I am including the first day of the month and the last day of the month so that I do not need to add or perform any date add or date diff calculations around prior month and 2 months ago. My next common table expression covers orders. We're looking at all of our customers and cross-joining months, so I will get 1 row per customer per month. Then I'll inner join to the first customer order virtual table, as we know each customer has at least 1 order. Finally, I will left join the orders table and get all orders tied to a particular customer ID and where the order date is in the range of first day of month and last day of month. Again, no need for date diff or date add here, simplifying this query a little bit. My where clause filters out any calendar months prior to the first order date. If a person's first order was in 2015, well, there's no reason to bring in records from 2013 or 2014, so this can reduce the number of unnecessary rows we're dealing with. In the select clause, we have the customer ID and calendar month, as well as 2 case expressions. The first checks to see if this is the first month for a customer. The second checks to see if we have an order in this month for this customer. Because we have a count function in the has order case expression, we need a group by clause containing our non-aggregated columns: customer ID, calendar month, and first order month. From there, we have a new common table expression, lagged orders. We take the set of orders and check for this customer sorted by calendar month what the value of has order is for the prior month. If we do not have a value, we use isNull to set the default to 0. That way we won't have any nulls to deal with in our final query. And there is one more common table expression here, monthly customer status. In this common table expression, we take the lagged orders and pivot the data based on calendar month. We get the sum of customers whose first month attribute is set to 1 as new customers, and we can look at the current and prior month's order counts to generate the remaining measures. Note that this is slightly different from what we did in KPI 5, looking at the number of customers. In that demonstration, we started in July of 2015, but looked at data from May and June of 2015. In this case, for July of 2015, we'll look at data from June and July of 2015. This is a 1-month shift, and it runs the risk of including incomplete data for the final month. But when you're looking at a larger number of months like this, I think this version of the calculation makes more sense. Finally, our base select statement starts from monthly customer status and includes the measures we saw before, as well as a calculation of retention rate. We calculate retention rate as the number of new and retained customers for this month divided by the number of new and retained customers in the prior month. In other words, we will not penalize later months for customers who churned a year or two ago. Let's run the script and see what we get. This takes a few seconds to get all of our results, but now we have data going back to January of 2013, in which we had 546 new customers. Note that the retention rate for January of 2013 is null because there is no prior month to compare against. Another point of note is that retention rate can be under 1.0, such as in February of 2013. In that case, we had 503 new and retained customers versus 546 new from January, so our retention rate is 92.1%. But if we look at April of 2013, we had 528 new and retained customers versus 485 in March, giving us a retention rate of 108.9%. In other words, based on the way we calculate retention rate, it is possible to have a retention rate over 100% if we bring back customers. This is a 2-month process, as the first month we bring an inactive customer back, that customer is resurrected and doesn't count in this formula. But if the customer makes another purchase, we have a retained customer once again. That was our look at customer-centric KPIs. Along the way, we brought in a few analytic techniques, starting with the DATETRUNC function in SQL Server 2022, then using calendar tables, using the lag and lead window functions to move forward and backward in time, and generating Cartesian products to fill in data gaps. In the next video, we will talk about a class of business metrics that relate to sales data. We'll have links and show notes in the description below, and until we see each other in the next video, take care.